Hi all, welcome to our new video in the course of machine learning. In the last video we have learned the basic definitions of machine learning, what is machine learning, different types, supervised and unsupervised learning. In this video we are going to see the basic terminologies that we are commonly using in machine learning. So the first basic thing, that is features. So what are features in machine learning? So in machine learning, as we have already learned, we have a history of data and we have a future data to predict. So the properties of or characteristics of that data is known as measurable, or the measurable properties of that data is known as features. So these features, we are using these features to predict the outcome y. So the features we are normally writing it as x1, x2, x3. All those variables or properties, they are known as characteristics of data, that is features. And using these features we are predicting our outcome or target variable y. And these features can be numerical. It can be numerical, that is, it can be age, salary, temperature, etc. Or it can be categorical. Then it can be text, reviews, tweets, responses, like that. Then it can also be image pixels, that is for computer vision task. It can, that is, the features can be numerical, categorical, text, or pixels. And we can see an example. So this we are taking the example of house price prediction. Okay, house price prediction example we can take. So in this house price prediction, we have the features or the characteristics as size of the house, view, that is size in square feet, view, that is no sea view, and bedrooms, number of bedrooms. So these are examples of characteristics or features in the case of machine learning data. And next terminology is feature vector, that is somewhat mainly related to the features itself. These numerical values, a list of numerical values representing the features of a single data point. For example, if you are taking house with 4 bedrooms, this one, if you are taking the example, this example, the 4th row as an example, 1504 square feet, 4 bedrooms with no sea view. The feature vector is looking like 1504, that is the square feet, 4 bedrooms, and 0. What does it 0 indicates? It is no sea view. That means this feature, that is view, can be written as no sea view can be categorized as 0 and sea view can be categorized as 1. So it's a categorical variable. It can be represented as 0 or 1. Hope this thing is clear to you. So we have learned features, that is the basic properties, and it is represented as a vector, that is known as feature vector. Feature vector is for a single data point. Okay, that's important. For a single data point, all the features combined for a single point, that is the feature vector. And a portion of the above features or the portion of the data set used to train or validate the machine learning model, that is known as the model learns patterns from this data, that is known as the training model. Okay, each row consists of features and the corresponding target also. And you can see if we have 100 rows of data, 70 to 80% is used for training. Okay, only 70 to 80% of the entire data set is used as the training set. So in this case, in the house price prediction, we will have, as we have seen earlier, square feet, view, and number of bedrooms, and also it will have the target value. It's important that the training set will have the corresponding target value, that is y also is included in the along with the data, that is known as the training set. And what is the target value? The list of corresponding output values. In our example, it is the price of the house. In house price prediction, it is the price of the house, that is the output value corresponding to each feature vector. So the example is given here. So in our example is the house price. This is the y. This is x1, x2. It can be represented as 0, 0, 1, 0, 1, 1 because it's a categorical variable, and it's the number of bedrooms. It can be written as 3. So in this case, y is a function of the house price, is a house price, that is the target vector. In house price prediction, this price is a continuous variable. So it's an example of regression. And if it's a spam detection, not spam or something like that, it can be a discrete variable. So it's a classification. So we can see the house price prediction, that's the target, is a function of size of the house, whether it has sea view or not, and the number of bedrooms. In this case, we can have very large number of variables, that is independent variables, that is affecting the price of the house. In our example, we have just taken, to show this example, we have just taken 3 variables. So this is example of target vector. Okay. So we have seen training set. This is an example of training set along with the target vector. Okay. Only of the total data set, only 70 to 80% is taken as the target vector. Sorry, 70 to 80% is taken for the training data set, and the remaining 20 to 30% we are taking it as the test data set. That is a separate subset of the whole data set used to evaluate the performance. Training set was used to train the model's performance, and using that algorithm we are evaluating the model's performance after training using the remaining 20 to 30% of the data set. It contains the features vectors, but it does not have any label, that is no target vector or no y will be there in the test set, and the actual y present we are using it to assess the model accuracy. The actual y we are taking to assess the accuracy of the model. So that is, we can see here we have all the data. If this data is 100%, the training data can be 70 to 80%, and the remaining data 20 to 30% of the data is used as the test data. And here I have written the Python code. We are using the function train test split. So this is our data and this is our label, and if you are giving that x comma y, and the test size is 0.2, that means 20% of the data is given for test and the remaining 80 is given for the train. So x train, x test, y train and y test, that will be given, that the data will be splitted according to this test size, and the data will be assigned to these variables. And the random states, random state we can assign any random number. The random state indicates that will be same data will be assigned to test and train. Even if we run it repeatedly, depending on a particular random state, the same data will be assigned to the test as well as the train when you run the same code repeatedly. The rows, even if, for example, if the first row is assigned for train, even if you run it second time, the first row again will be assigned to the training data set, like that. That means the same row, same number of rows will be assigned to the training data set and test data set even if you run the code repeatedly. That is why we are assigning the random state equal to a particular number. Okay. So that's all regarding the basic terminologies. In the next video we can go over overfitting and all those concepts. I hope this video is useful to you. Okay, thank you.